Okay, we are in this notebook, lots of neuroblastoma data sets. We just covered plotting two clinical variables. The first one was the MYC-N status versus the MYC-N gene expression, and the high-risk status versus the MYC-N gene expression. Let's now move on to the part 3, the survival analysis. I'm not going to discuss so much what the survival analysis is because it's going to be clear when we plot the figure. Let's take a look at this first chunk here. So what the note that I put here was we want to make the overall survival status numeric instead of character. And there's a series of steps that's required for that. The first one is to construct this OS being numeric variable, and we are using the mutate function from the dplyr library. So you see here the OS underscore being underscore numeric. And you're seeing that we're using an if-else statement. And we are also using this OS underscore being variable. Before we run this command, let's take a look at what this OS underscore being variable looks like. In order to do that, let's take a look at this OS underscore being variable in RStudio. So I need this object, and then $, and then OS underscore bean. So if I hit enter, each one of these numbers here represents an index, and it's an index for a line, and each line in this variable, okay, you can understand this is you can think of this as a column of this data frame. There's so here in RStudio is better. Now I can use the view function. Let's view R2 underscore GSC. So you can view this, and it generates this very nice visualization of the data frame. Again, we can see here that this is a data frame of 498 lines and 25,000 total columns. And if I go back to the console here, we just looked at the OS underscore bean. Let's see this one here. So you can see that each line is a patient, and you already have the GSM and the numbers indicating each one of these lines. Each one of these IDs here is the ID corresponding to a patient. So the OS underscore bean, again, each one line here represents the event or the non-event of each patient. And because this is OS underscore bean, that stands for overall survival binary. And what that means is whether the person had the event or that they did not have the event but at this time. And the event means basically death, unfortunately. So what I need to do, what this is doing, is it is transforming the event, the word event, into 1, and the word non-event, no event, in 0. And if I do not do that, R is going to throw a bunch of errors at us, and we would not be able to generate the survival plots, which we're going to generate in a minute. So I am going to go ahead and copy this and paste it here. Ideally, we should have written this down. And if I hit enter here, it's giving me this error because it's complaining about this operator, the percent bigger than percent. And this operator comes in the function that I called at the very beginning of this notebook, the mediter function. So I'll have to come here and I have to type library medi, it auto completes for us. So I just loaded this library. So if I go back to this line, that was the line again that was creating the OS underscore bean underscore numeric variable and making it so that it is 0 and 1 instead of event, no event. So if I run this now, it basically ran through. And let's see. So if I scroll all the way to the right, it's not going to show me the OS underscore bean underscore numeric column. I think it's going to be at the very end. So if I click this, I'm asking it to basically show me the very last column. And here you can see the OS underscore bean underscore numeric column. You see ones and zeros. And if we were able to compare the OS underscore bean variable with this OS underscore bean underscore numeric, we would see that ones corresponds to events and zeros correspond to non-events. And so the next command here for us to run is to make that variable numeric. So one way, let's check here very quickly. I'm going to ask R, what's the class of OS underscore bean underscore numeric? And of course it's telling me that it's a character, but I need to change that. I need to make that numeric. And this is the line that changes that. And if I ask R again, which class that variable is, it tells me it's numeric. Here I am doing the same, but not for overall survival. I'm doing for event-free survival. And then we're going to basically, so event-free survival is how much time the person can survive without the tumor coming back or relapsing, okay? And so here we are doing the same thing. We're creating this EFS being numeric variable and also making it numeric. Now we move on to the survival plots. The first thing that we do is we construct the survival curve, and we're going to basically generate a model. I'm not going to discuss what that is or how that is done. I'm just going, basically here we're just showing how it is done in R. So I have to load the survival library. Okay, it's finished. And let's discuss just a little bit of the syntax of this command. We need to use this survival fit, the survfit function. And this function is taking two arguments. The very first argument is the number of days that the person survived in this study. So what this OS underscore day variable is, we can take a look at it. OS underscore day. So it's the R2 underscore GSC OS underscore day. So that's different than the bin, right? And so you can see here that the each line is a number, but note that the number is in between quotes. And exactly because they are in between quotes, if I ask R, what's the class What's the class of this? R is going to tell me it's a character. That's why you see that I have to make that variable numeric. And I can do that using the serve fit. And let me say it in a different way. I can make the variable numeric as I apply the serve function here. And so the other parameter that this function takes is the OS underscore bin underscore numeric. Remember that we just constructed this variable, and this variable is 1 and 0, telling R whether the person has survived or not for a certain period of time. And then we want to visualize what the survival curves are for the high risk variable, okay? And that's what this part here is telling us. And this all is going to be visualized using, of course, the R2 underscore GSC 62564 underscore GSVA underscore metadata data set. And that needs to be specified using this data parameter, which takes the data frame that we are studying. So I'm gonna copy all of this. So you can see here that I called the object that is going to be generated fit underscore OS underscore high risk, because I'm going to visualize it using this high risk part, right? So let me ask R what this fit underscore OS underscore high risk object is. So it shows us this output. It says call serve fit for the formula, uses the serve function that I just discussed. So this part is the formula of the survival analysis. Now in the part in the bottom part, it does some sort of summarization of the high risk group that is not high risk and the high risk group that is high risk. So there are 222 patients that are not belonging to the high risk group and 176 patients that do belong to the high risk group. Another thing that is interesting here is that there are 13 events in the people that do not have high risk, and there are 92 events in the group of people that have that are of the high risk group. That makes sense. That it makes sense that there are much more events in the high risk group. Apparently, this is the median number of days that each group survived. It's not applicable, the number of days that the high risk, that the non-high risk people survived. Maybe that's because these people are still alive, or they were alive by the end of the study. And for the people that did have high risk, the median survival was 1362 days. And then these intervals, I'm not going to, I don't think it's worth discussing this. Okay, so we constructed the survival object. Let me actually go ahead and ask R what class the fit. It's a serve fit object, okay? And what we do next is we're going to generate the survival curve. And for that, we need this serve miner library. So let's load it here. So we're going to use this ggservplot function, ggservplot function, and we're going to use the fit underscore OS underscore high risk model that we just constructed. We are going to specify which data set we are using. Maybe I'll mention what the risk table is in a minute. We're going to ask it to generate a p-value for us because we want to know whether there is significance in the survival, comparing the two groups that we are comparing. Again, we're comparing the high-risk groups. There are only two high-risk groups. And this p-val dot coordinates is just the coordinates of the p-value where we are going to plot the p-value. So I'm going to copy this here, and I am pasting it. And I was able to generate a visualization. So this is what a survival curve is, okay? So this curve, in the x-axis, we have time and time in days. So you can see here, 0, 2,000, 4,000, 6,000 days that this study lasted, more than 6,000 days, that these patients were under analysis, that they participated in the analysis. And in the y-axis, we have the survival probability. There's a complex math that is used to calculate the survival probability. And we have the high-risk group that you see here in blue, and the non-high-risk group that you see here in red. So the patients that belong to the high-risk group, unfortunately, they have a much lower survival probability. So this basically means that their disease is much more aggressive than the non-high-risk group, and that's why they have lower survival probability. Unfortunately, a much higher number of these patients end up dying by the end of the study. And so this is what would be the risk table. I set it to truth here. The risk table basically shows us the number of people that are at risk and how much that decreases over time. So we start with 322 people in the non-high risk group and 176 in the high risk group. And by the end of 2,000 days, 2,000 days here, we have 204 patients and only 46 patients in the high-risk group. You can see here how severe the disease is. Majority of the patients are dying by day number 2,000 here. By day 4,000, only 4 patients in the high-risk group are alive, and by the day 6,000, only 1 person is surviving. So this is basically what a survival plot is. We can compare what survival rates we have in two or more different groups. In this case, we just analyzed a survival curve for comparing the high risk group of this neuroblastoma cohort with the non-high risk group, and we see that there's a very high survival probability of patients that do not have high-risk disease. Thank you for watching this video. I'll see you in the next time.